Number 4. Prove that the function f of x equal to x to the power n is continuous at x equal to n, where n is a positive integer. For solution, given that function of x equal to x to the power n at x equal to n, left hand limit equal to limit h tends to 0. f of x is equal to f of x equal to x to the power n. So x is n minus h equal to limit h tends to 0 f of x. Then instead of writing x, we have to put n minus h. N minus h to the power n. Let us put the values of h equal to 0. Now n minus 0 upon raised to the power n equal to n to the power n. Right hand limit h approach to 0 f of n plus h equal to limit h tends to 0 x is n plus h to the power n. Limit h tends to 0. Let us put the values of h equal to 0. Now n plus 0 raised to the power n equal to n to the power n. And f of x is n, which is equal to n to the power n. We have left hand limit equal to right hand limit equal to f of x. All these three are equal, so f is continuous at x equal to n. Question number 5 is the function f defined by f of x equal to bracket x comma if x is less than or equal to 1, 5 comma if x is greater than from 1. Continuous at x equal to 0, at x equal to 1, at x equal to 2. Let us find out, or let us check the continuous at 3 different points: when x equal to 0, x equal to 1, and x equal to 2. Question number 5. Solution. The given function is f of x equal to bracket x if x is less than or equal to 1, 5 if x is greater than from 1. From this inequality equation, we know that the function is different for different domains. If x is less than or equal to 1, the function of fx is equal to x. If x is greater than 1, if x is greater than 1, the function of fx is equal to 5. Function of fx is equal to 5. Let us check the continuity at x equal to 0. Here 0 is less than 1. So function of x is equal to x according to the equation. Let us find out the left hand limit. Left hand limit is given by is equal to limit is approach to 0 f of x equal to limit is approach to 0 f of x is equal to 0 minus h. That is from the left hand side equal to limit is approach to 0. F of x is equal to x. So f of minus h. F of x is equal to fx equal to limit h approach to 0 minus h, which is equal to 0. That means which is equal to 0. Putting the values of h equal to 0, we get 0. Again, right hand limit equal to limit h approach to 0 f of x equal to limit h approach to 0 f of 0 plus h. That means from the right hand side equal to f of x equal to fx. So limit h tends to 0 f of x is h. Then limit h approach to 0 h. Then let us put the values of h equal to 0. Then we'll get 0. And f of x equal to 0. So we put a 0. F of x equal to x. That is 0. We have left hand limit equal to right hand limit equal to f of 0. All these three values are equal, that is 0. So f is continuous at x equal to 0. Again, to set the continuity at x equal to 1. Given function is that f of x equal to x if x is less than or equal to 1. 5. If x is greater than 1. Here x equal to 1. So the value of fx is take as x. That is f of x is equal to x. As set continuity at x equal to 1. Left hand limit is given by is equal to limit x approaches to 0 f of x equal to limit x approaches to 0 f of x. F of x is equal to 1 minus h, means which is from the left hand side equal to limit h tends to 0 f of x is equal to fx. That is 1 minus h. F of x is equal to x. Okay, so we need to write f here. 1 minus 0. That means let's put the values of h equal to 0 here. It is 1 minus 0, which is equal to 1. Since f of x is equal to x. Right hand limit is equal to limit is approach to 0 f of x equal to limit tends to 0. F of x is f of 1 plus h. X is equal to 1 plus h, which is from the left hand, which is from the right hand limit, equal to limit 1 plus h. That means 1 is greater, so f of x is equal to 5. Here, left hand limit does not equal to right hand limit. Hence, f is not continuous at x equal to 1. To check the continuity at x equal to 2. In this case also, x is greater than from 1. So f of x is equal to 5. Left hand limit is equal to limit as approach to 0 f of 2 minus h from the left side, equal to limit as approach to 0. F of x is equal to x. X is here. F of x equal to 5. 5 equal to 5. Right hand limit. Limit f of 2 plus h equal to limit 2 is greater than from 1. So f of x equal to 5. 5 is opposed to 0. That is 5. F of 2 is also 5. All these three values, that is left hand limit, right hand limit, and f of 2 on are equal to 5. So f is continuous at x equal to